So, hi everyone, my name is Nina. I'm a software engineer at Facebook, and I currently work on a team that manages Facebook's deployment infrastructure, so pretty much containers, containers, containers. Before this, I was at EC2, where I kind of worked on a whole bunch of things. And like many of you, I've experienced being awake at 4 a.m. Watching services and servers burn to the ground. However, my background is primarily as a software engineer, and I work as a software engineer now, which means I'm trying to look at this from the other side. I've done a bunch of SRE work. My day-to-day work involves a whole bunch of SRE work. So I feel like I have some sympathy, if not empathy, about what it's like as an SRE to work with software engineers. Because at the moment I'm also working on a mixed team of SREs and software engineers, I'm also going to talk a bit about how this generally works at Facebook. So before I go any further, let's talk about the bad old days. This was where there was strong separation, lots of kind of throwing things over the wall. Sorry, slide went too fast. Cool. Lots of throwing things over the wall, and because there were very different teams with very different kind of objectives, it meant that there was often a lot of animosity and missed kind of communication because people weren't exactly working together and often working at cross purposes. And the problem with this is that it doesn't scale. To write scalable code, you need to understand the systems under them. And to debug these systems, you need to have some idea of the code. For example, at scale, you can't just SSH in to delete or change a file on hundreds of thousands of machines, or just restart the servers, or assume every environment will be exactly the same. Working at scale successfully requires awareness of what scale actually entails. And there are, you could say, three main development ideologies around how to manage teams working in these environments. The first, as I've already mentioned, is the siloed approach. You have different teams with very different responsibilities, little overlap between them, and little conversation between them. Then you have what I refer to as the startup approach, which is one or two people kind of trying to do all the things. And finally, you have the D word, DevOps, which I mean more in the philosophy sense. And for those unfamiliar with this term, DevOps refers to a cultural movement or practice that emphasizes the collaboration and communication between software developers and other tech professionals, for example, people in ops or QA. This is done so that building, testing, and releasing software can happen rapidly, frequently, and more reliably. And the emphasis of this is kind of on the performance of the entire system, rather than the performance of a specific subsystem or team or department, that sort of thing. So what does this actually mean in practice? So with a siloed approach, because you have very different teams working sometimes on conflicting goals, there's often a degree of animosity that arrives because goals may conflict across the teams. And not only that, there is a real monetary loss from the separation. So to give you a real-life example of this, back in the day at Facebook, engineers wrote up a system that required being co-located in the same rack as another system because of latency. They finished writing the system, handed it over to the deployment people who deployed it and kind of went on with their lives. However, as over time, top-of-rack switch bandwidth improved, and engineers were able to architect away from this limitation. However, because of the lack of communication between software engineers and people doing the deployment, no one told the deployment team. And this meant that for a very long time, these services continued to be co-located in the same rack. And when this finally came to light, they were able to improve utilization of machines. And this, of course, means a drop in cost. So this is what I mean when there is a real dollar value tied to pretty much every day that this communication wasn't happening. The other approach is kind of do all the things. And this really makes sense at small companies where you have a couple of experienced engineers who can help guide others and help other people grow. But it becomes more and more difficult as companies grow. It has a pretty steep learning curve and requires really good mentoring. If you think of what it takes to get a service into production, there's actually a really wide range of components, which means that as a kind of new engineer coming in, it takes a really long time to become effective and efficient at what you're doing. Finally, at Facebook, we try to take a more middle path to all of this. The engineers we have filling this kind of SRE role are referred to as production engineers. And to explain what that means, according to Wikipedia, a production engineer typically has a wide knowledge of engineering practices, is aware of the management challenges related to production. The goal is to accomplish the production process in the smoothest, most judicious, and most economic way. In other words, save money. These abilities are fundamental for the performance of coordinating and integrating professionals of multidisciplinary teams. So this name was chosen for a couple of reasons. The first being that it was purposefully distinct from terms like SRE, SRO, sysadmin, ops, because people have existing preconceptions of what these terms mean and what the type of work related to them is. It's also because the description I've just given largely sums up the desired role for these engineers at Facebook. So what exactly do these engineers do? They're hired with different characteristics in mind when compared to software engineers. And I find that when discussing what some job title means, it's often useful to look at what characteristics people are hired for into this job. So in this case, there's no one-size-fits-all mold. We have systems generalists to specialists in areas like networking, hardware, databases to compilers. However, there is a common theme through all of these people. In general, they think about and enjoy things like scalability, reliability, automation, whereas software engineers are more concerned with things like speed, performance, new features, and that sort of thing. And this is really strongly visible in the hiring process. So Facebook, like many other companies, has a hiring loop that consists of a bunch of different interviews. And there's definitely overlap between them. We have the would I like to work with this type of person interview, large-scale system design, and coding. However, for a software engineer, there are also interviews that involve coding and coding. So as you can see, it's pretty coding heavy. However, for production engineers, we focus on a bunch of other things. So while production engineers are expected to be able to code, there's more of a focus elsewhere. And I should mention here that we don't give production engineers 5 different interviews because we expect them to nail all of them. We expect them to nail 1 or 2, with the idea being that we're looking to hire subject matter experts. So what I'm trying to get at here is that there's a common base. Everyone at Facebook all the engineers at Facebook, I should say, is expected to be able to code and should be able to think about large-scale systems. However, the strengths between PEs and software engineers are different. And that doesn't mean that we divide people based on them. PEs are, in fact, generally embedded within software engineering teams. And this idea of having one team is pretty important. So I should also say at this point that not every team has PEs on it. They're generally allocated for large production systems that require high levels of reliability, scalability, and that sort of stuff. But however, that being said, rather than the idea of there being kind of PE work and software engineering work, we just have work. And this is because people are good at different things. And by not creating the division of responsibility, there's a lot more overflow between these various areas. And part of the role of having PEs on a team is, in fact, to upskill the software engineers to release their own code, add monitoring, start to worry about reliability, that sort of stuff. And this is a two-way process. The production engineers gain exposure to skills that software engineers may be more familiar with, things like building features fast, optimizing things, architecting large code systems, and so on. So it's really a two-way exchange here. And related to the idea of having only one team is the idea of one on-call, which I like to refer to as nothing at Facebook is someone else's problem. And I should clarify that all engineering teams have an on-call, regardless of whether there are PEs in them. But teams that do have PEs have exactly the same on-call as the SREs. They're all on the same rotation. And this is because both roles are then equally responsible for supporting the code, which also means that they're equally responsible for writing supportable code, and as well as testing it. So there's no throwing it over the wall here. Plus, as a bonus, there's a certain sense of camaraderie that comes out of watching your infrastructure burn. So that's bonding experience. And so after me pointing out all these similarities and the way we do these things the same, you may be wondering what's the point of even having 2 different roles here if they do exactly the same work. And this comes down to one thing, which is a different reporting structure, which means that the focus for these different roles is different. And having a different focus means that different behaviors are expected and rewarded. So for example, a software engineer is meant to produce and ship features. A production engineer, however, while they'd still be rewarded for doing that, is also expected to do things like scale systems, improve the reliability, improve uptime, help developers release code more quickly, and that sort of stuff. So what this really means is that software engineers and production engineers have different strengths, which means that on a team there's less conflict of interest. Production engineers can work on things like reliability without it necessarily affecting their overall performance. And this means that while at Facebook nothing is somebody else's problem, PEs are explicitly tasked with and rewarded for how services grow, whether this manifests as work around reliability, developer efficiency, automation, and so on. Another important bit about production engineers that's helped by having this different reporting structure is that they have a lot of mobility. And this is really important because PEs form such a small percent of the production engineering org, like of the engineering org, say 5% overall. And that means it's even more important that when they do join a team, that they infuse it with the ideas of reliability and scalability so that the software engineers on that team are able to kind of continue that on once they've left. And equally important is for them to be good at understanding the code that they're working with and building relationships with the engineers that they're working with, because good relationships in general mean better collaboration. So I've kind of given a whirlwind tour of what the SRE style role looks like at Facebook. So I'm now going to talk a bit about what I feel helps the interaction work well. And this is from my experience having worked on the other side. So the first thing is to roadmap together. Share the same vision, work towards the same goals. And that doesn't mean that you have to work on exactly the same areas. Individuals can have different focus areas, but it does mean that everyone is agreed on what success means. And that's super important later down the road where you may have conflicting priorities and that sort of thing, because it helps to resolve this, because everyone's agreed to work towards the same goal. Also related to this is the idea that everyone should be involved in the whole software lifecycle, so no throwing it over the wall. The system is everybody's responsibility all the time. And this in turn also helps to encourage ownership over the code, because you own it the whole way through. It's not that you write it and then hand it over, or you deploy it and you have nothing to do with what's actually being deployed. And I've already mentioned this, but I really want to reiterate the fact that having the same on-call means that if you're responsible for supporting something, you're a lot more likely to design for reliability and to set aside time for making things more reliable, because you understand the real effect of this. And I'm saying this more from a software engineer point of view. Having been on call for systems, I really appreciate reliability work. I would definitely like to be paid less. And a lot of this can be summed up as the idea of sharing responsibilities. And this is done by removing the separation between ops and dev work, so that if you don't have the skills, you can ask someone for help. And if someone else doesn't have the skills that you do, you're able to offer them help. And this may be a bit controversial, but in my opinion, if you're working with software engineers and they keep making the same dumb mistakes, that's as much your fault as it is theirs. Because if you can teach them not to make these mistakes, everyone benefits. So this is kind of around the idea of sharing skills, because people like me don't write unreliable or unscalable code on purpose, or because we're lazy and we don't want it to work or that sort of thing. We do it because we don't understand or we don't know how to get help about this. And there are definitely software engineers out there who have no interest in learning about this or improving their systems in these ways, but there are people who do care and would be interested in gaining these skills. It also comes down to the concept of diversity of thought, which is a very popular term, buzzword that's often thrown around. But in this case, it's really about thinking about the same problem but from different perspectives. And this can be really valuable. Because while we may think about it from different places, ultimately everyone wants the project or system or whatever it is to work. And the flip side is to realize that that software engineer who just randomly deleted binaries out of /bin and expected everything to work fine was hired because they were good at something. And maybe that something else is worth learning about. So what I'm trying to get at with this is that different strengths can really be a good thing. And to give you a couple of concrete examples of this. So while I was at EC2, a bunch of critical systems running in memory and CPU constrained environments were written by people who had much more of an ops background. And they chose to do this in Ruby. And Ruby's great. I'm a fan of Ruby, but it is not known for its memory efficiency or speed of execution. And this meant that, especially as these systems got bigger and bigger, there became more and more overhead from this. Insight from people who had experience writing these sort of systems would probably have been helpful. Conversely, the system I work on at the moment is responsible for creating and managing containers and their environments. It's pretty much done all in C++, including the bits that do the provisioning inside the containers. Plans to offload more of this to existing provisioning systems were spearheaded and piloted by production engineers. And this isn't particularly surprising. Given their background in operational work and their familiarity with provisioning systems, it's not surprising that they saw this opportunity and went that way. It also isn't particularly surprising that developers like me, who are much more used to doing things around C groups, concurrency, dangling pointers, that sort of thing, didn't think of this. But that's okay. Because we have a culture of collaboration, we're now working together in order to implement a system like this that manages both those ideas in. I think what I'm trying to get at around all of this is that while some people have no interest in learning about improving reliability or any of that sort of thing, some people do, and these people could become your kind of people. Overall, be patient. You know, the things that are obvious to you probably aren't. I'm sure you can think of things that now are second nature, but when you first learned them or first saw someone doing them, they were pretty difficult or difficult to grasp, and it required someone else to just take a bit of time and explain them to you. So what I'm trying to get at here is the concept of communication. The standard model of this not working is when, say, a developer changes requirements and then expects everything to just magic work. However, I've definitely run into the opposite. So again, a real-life example. One of the production engineers I've worked with changed a deployment mechanism for a daemon that went out to hundreds of thousands of machines. And this is standard stuff, right? However, he didn't let the software engineers working on that code know about the change because deployments aren't a software engineering issue, you know? And this difference in assumptions about basic mechanisms like this caused outages and breakages. It also introduced a bunch of artificial constraints that meant writing and releasing new code became much more difficult and time-consuming. And overall, this took a great deal of time, of developer time, to resolve. And this is pretty sad, because it could have been resolved with a simple conversation over lunch one day. And this is what I mean about there being an actual dollar value tied to this lack of communication. Basically, we all have different blind spots, and this hurts us and the systems we work on. Titles are just titles. They're, at best, a description of the skills you had when you were hired. One role doesn't own certain skill domains. And what do I mean by this? So I've had ops people and production engineers react differently to my suggestions or be more dismissive, ops-plain things to me. And I'm sure, on the other hand, there are people here who've had experiences where your code gets rejected because you're in ops and ops people aren't meant to code. And this kind of sounds obvious, but people are relatively unique. And while titles are good for putting people into boxes, and that's a totally understandable, understand the world brain mechanism, taking the time to regard a person as an individual is vital for building a relationship with them. And building a relationship with them is in turn vital for working successfully together. After all, we're all in this together. Questions?
Great talk. I just had a question around the culture, I guess. Have you seen many teams that need to be, I guess, reformed or readjusted based on, I guess, the people who don't want to know about reliability or don't care?
Not really. I don't think this is... If you're working in an area that requires high reliability, you kind of... Yeah.
So why 2 reporting chains? So is it to manage to the lowest common denominator of manager that doesn't understand the incentive structure for both?
No, this was done very purposefully, and it's kind of that people, it's not that people who work on reliability, because not everyone wants to, and there's definitely a value for getting features out, so that the people who are interested more in reliability and do more of that work are equally rewarded for it. That there's a team that kind of has this as their focus on it. They're specifically tasked with working in this area.
So but that would just mean that the people evaluating that don't understand the problem.
I'm not sure that follows. It's more that you have people who have this specific goal as part of their everyday. Okay.
What about production access? Do both roles have same amount of access to production systems?
Yeah, exactly the same. I mean, production access is more dependent on what part of infrastructure you're working on than what your role is.
Okay.
Sorry, 2 questions. How important do you think hiring quality is? I've seen some scenarios where if an engineer kind of isn't up to par and they get mixed with the development team, there's a level of respect they may not be able to obtain to get that kind of trust that they need. And the second part was broaching on-call for the first time for like large organizations. So I've been in kind of both scenarios where you have smaller companies where it's just kind of accepted, and then you have larger companies that it's a new concept that needs to be introduced and there's a lot of resistance. So yeah, how would you suggest overcoming kind of the larger company integration of on-call?
So I guess this is a bit of an easy case at Facebook because there has been on-call forevers, and it's more just that people are on the same rotations. I guess moving this into a company, it would be about bringing it in slowly and teaching people about the value of it. I mean, maybe that's just about getting people to see what's required when they deploy bad software or untested software. With your first question, because people are all hired to the same bar, so production engineers are expected to code, they just have other skills as well, this isn't really an issue. Or at least I haven't seen it as an issue in my time working at Facebook.
Hi, you'd mentioned production engineers at Facebook. There's a lot of mobility between teams. I was curious, is it more typical that a production engineer would work with the team on a shorter scale time frame, and once some reliability issues are fixed or the operational culture amongst the team is increased, they'd move on to other things? Or would a production engineer stay working with a particular engineering team or feature for a longer period of time?
It really depends on the feature and the team.
Okay.
So you have both, yeah.
Thanks.
So I see you share the same roadmap between software engineer and production engineers. I think this is a great approach. My question is, during my daily work, there seems there a lot of conflict between the operations and the software part. It's because from operations point, so I have a working flow, operation flow from A to B to C, right? Now I need software engineers to help me to make it automatically happens, right? This is ideally, that's why I need you, right? But from software engineers' point of view, okay, you have A and B, C, but if this is not optimum, then probably today I can build it for you, right? You may happy, but after 6 months, I may need to build another one from C to A to B, or even for D, right? This is from software engineers' point of view, basically, we need some level of generalization, optimization before I start build a system, right? So when you build this roadmap, for example, you may see similar things from operations and from softwares. So how do you solve this problem? Make the two part of people have the same roadmap.
So I think it's about deciding on a higher level goal. So if you want to deploy feature X, you may have to include building things from between A, B, and C, but everyone is working towards deploying feature X. If you can show that creating generalized automation or that sort of thing is going to get you to feature X faster, it's basically about showing the value of the work that you're doing, and that's from both sides. I'm not sure if that answers your question.
Okay.
Okay.
Yeah, I think it's good. Thank you.
So I think you mentioned that production engineers and the software engineers work together in the same team, but they have different reporting structures. How does the performance review work for the production engineers, given that their manager might not physically sit with them or be in the same working area as them?
So production engineering managers are involved as much in the team as the software engineering managers. It's not that you'll have a production engineering manager that manages a super diverse and dispersed team. Yeah. Any other questions? Thanks very much.